Hello and welcome to the third video on measures in distributions. This time we will talk about measuring the position, but please make sure to review the videos on measuring the center and spread before moving into this video, as they provide some necessary knowledge that we need to use today. Returning to the subject, this video is going to equip you with the ability to describe position of any other values besides the center. There are three important recognized procedures for designating position: simple ranking, percentile ranking, and z-score. Simple ranking is an easy concept. All we need to do is to arrange the elements according to some statistical characteristics and note the position in that arranged order where a particular value falls. For example, here we have some pH values of some common drinks, and we want to know how acidic is fruit juice compared to the other drinks in this group. So we arrange the data according to the pH values, and we can conclude that fruit juice ranked the third acidic drink among these common drinks. Simple ranking is useful even if no numerical values are associated. For example, from the metal activity series, we note that lithium is the most active, then sodium, followed by magnesium, iron, and finally copper. Here we can see that iron has a simple ranking of 4 out of 5. Percentile ranking is helpful when it comes to comparing positions with different bases, i.e., comparing data within data sets that have different sizes. It indicates what percentage of all values fall below the value of consideration. Let's do an example to illustrate. Here are the students' GPAs in two classes of different sizes. We want to think about the ranking of students with a GPA of 3.2. Now, we arrange the data from highest to lowest. As we can easily see, if we use simple ranking, the student in class 1 ranks 3rd, while the student in class 2 ranks 6th. That's a big difference. But one may say, hey, that is unfair, because the class sizes are different. And that's why it's more useful to use percentile ranking. Since there is one GPA lower than 3.2 in class 1, and the total number of students is 4, the percentile ranking is 1 over 4, which is 25%. There are two GPAs lower than 3.2 in class 2, so the percentile ranking is 2 over the total number of 8 students, which is 25% as well. Therefore, the two students with GPAs of 3.2 are actually in the same position in their classes in terms of their GPA. Z-score is a measure of position that takes into account both the center and the dispersion of the distribution. It states very specifically by how many standard deviations a particular value varies from the mean. It is mathematically defined as z equals x minus mu, and then divided by sigma, where x is the raw score that we are considering, mu is the mean, and sigma is the standard deviation. Here is an example. We want to find the z-score of this value over here. In this set of data, we are given that the mean is 5, and the standard deviation is 2/3 of root 10. Now we plug in the values into our formula, and our answer is -3 root 10 over 10. Notice that for the values that are smaller than the mean, the z-score is negative, and for values that are greater than the mean, the z-score is positive. Recapping, today we learned to measure position in distributions. We introduced three main procedures for designating positions, which are simple ranking, percentile ranking, and z-score. We also compared the effectiveness between simple ranking and percentile ranking. And that's all for today. See you soon!